This is Josh White with JW Math Tutoring. Today's video, I'm going to cover the 6 hardest problems from the April 2023 ACT Math exam, Form F11. So let's go ahead and get right to it.
But life is a dream that calculus could never predict.
Just before I begin this video, going through these 6 hardest ACT problems from this test, I just want to mention a couple things. First, if you like this video, please do give it a thumbs up, subscribe to my channel, sign up for notifications. Second, the reason I'm only highlighting 6 problems from this test is because I've gotten hit with copyright strikes from the ACT when I published full reviews of completed official tests. So that's the reason why you only see 6 problems instead of the full 60, which I would love to do, full videos on. Lastly, if you're looking for more ACT practice work, please check out my Improve Your ACT Math Score course. You can find it on Udemy. You can find it also on Teachable. There are direct links to both courses in the description of this video below. And basically, this is a comprehensive overview of the math section on the ACT. It covers your common topics in algebra and geometry and probability and statistics, in addition to strategies like back solving, picking numbers, process of elimination, estimation, drawing a picture, essentially in order to help you solve problems as quickly as possible. And it also includes an entire module on using the TI-84 graphing calculator to solve problems as well. Basically, it features over 10 hours of instructional video along those 5 different modules. So please do check that out. Anyways, here are the solutions to these 6 hardest problems. Looking at question 42 now. Here you have one where it's talking about finding an expression for the total amount of time it took this person to run this race, given that he went at a certain rate initially and then went at another different rate for some, the rest of the race. Okay, but the thing that's a little tricky here is if you're normally we're used to, rate times time equals distance, right? That formula. However, what makes this a little tricky is that the rates they give you here. So notice if you solve this for time, right, you get distance divided by rate. In other words, think about a car, miles per hour or meters per second. All right, these rates are actually reversed. These rates have the time on top, or the on top, and then the distance on the bottom. So in other words, minutes per mile, as compared to normally like miles per minute or miles per hour, or whatever. So that's what's just a little confusing right off the bat. So you're actually not going to use this formula at all. So first, I'll just go through the theoretical way to solve this, and then I will show you also how you could use picking numbers to figure out which is correct. So if he runs X miles at a rate of 7 minutes per mile, notice to get the time, you're just going to multiply those. Think about it, 7 minutes per mile, and you go for X miles. You go ahead and you multiply those, the miles cancel out, and you just get a time, basically, of 7x minutes. And then for the rest of the race, it's now 8 minutes per mile. But how many miles is it? Well, they tell us up here in the given information that it's a 5-mile race. So if you ran for X miles, then the remaining distance is going to be 5 minus X. And you could just think about this in terms of numbers, and I'll get to this when you do the picking numbers, right? If he did 2 miles initially, then the remainder would be 3 miles. And you get the 3 by just doing 5 minus 2. If he ran 1 mile initially, then the remainder would be 4, but just by doing 5 minus 1. So following the same pattern, the total time would be 8 times 5 minus X. So you just add these two things together, and that would give you your total time. So the correct answer to this problem is letter K. Now, here is how you could do this by doing picking numbers. So I let x, the number of miles for the first segment when he ran at a slower rate, be 3. Okay, so basically I just plugged in 3 and that gave me 21 minutes. That meant that for the rest of the race, which is 2 miles, total time worked out to be 16 minutes. Just 8 times 2. So total time overall, 37 minutes. Now you just go through all these answer choices, plugging in 3 for x, and only one of these is going to equal 37. If you do it in J, it's 3 minus 5, which is -2, and this is going to give you a negative number, which doesn't make sense. Or actually, no, it won't give you a negative number because it'll technically be 7 times 3, 21, minus 16, so it would be 5, which is wrong. And same thing here for H. If you plugged in 3, it's going to be 21. Let's see here. Does this work out? 21 plus, no, 24, because X is 3. 21 plus 24. 45, that's obviously wrong. And you could do the same for F and G, but they're going to be fractions, so they're obviously not going to be equal to 37. So correct answer is K. And again, that's how you could use picking numbers just to solve it. All right, now let's look at the one directly below it, where it wants to know the probability for um, a person who wins this raffle that did not finish the race. So you have to scroll back up here, look at this given information that they're told you here, specifically, this part underneath the table. So 90% of all people started the race. Okay, so it's like you started with 100 people, and therefore, of those 100, only whatever 90 of them actually started, or 0.9. And then of the people who started, 95% finished. So then, 95% of 90, that would be the people that actually finish, versus do not finish. So you take the, say, the 0.9% of people that started, 90%, and then you multiply that by 0.95% of people that finished the race. So these two things multiplied together, this is the percent of the overall people that registered who finished the race. Okay, it comes out to 0.8, something whatever. The reason I'm not multiplying it out is because in the answers, notice it's not they're not multiplied out. So this is the percentage of people that finished the race. So what is the percent chance that the person who was selected did not finish the race? Well, you either finished the race or you didn't. So therefore, it's just going to be 1 minus this. So 1 minus 0.9 times 0.95. So in other words, this percentage, whatever it is, it's like, 0.81 something, 0.82 something. 82% of people finish the race. Therefore, 1 minus that are the percent of people who did not finish the race. Either because they didn't actually start it, or they did start it, but they didn't finish it after starting it. There's technically two groups of people that you could, fall into that category. And the reason is because the two probabilities have to add up to 1. You either finished the race or you didn't. And together they add up to 1, or 100% of the people who registered. So the correct answer for this one is just going to be letter E. Let's look next now at the top of the page, number 48. So this one is just kind of annoying because it's a lot of algebra work, and I don't think there's necessarily a shortcut way to save much time. I mean, what I did is I first combined the first and the third terms here, rational expressions, because they have the same denominator. So I just made that 2a minus b, over a plus b, and then plus the b over a minus b. And then the next step, you have to get the common denominator, which is just a plus b, a minus b. So we have to multiply both the right one, a plus b over a plus b. The left one, we're missing an a minus b over a minus b. Now, so the denominator is going to be a plus b, a minus b, or you could also just write that as a squared minus b squared. So on the top, now we have the FOIL on the left, distribute on the right. So foiling out 2a squared minus 2ab. Let's see, that's the inner, outer minus ab, last plus b squared, and then distributing plus ab plus b squared. So now we can combine our like terms. B squared plus b squared, 2b squared. Now, so get rid of that. Negative ab plus ab, these just cancel out, so we just are left with the minus 2ab, and then 2a squared. Then again, the bottom, however you want to write it, doesn't matter. I'll just do, I guess, a squared minus b squared. So now let's go look at some of the answer choices here. On the top, you can factor out a 2, but I don't believe you can factor it any further after that. So the bottom's going to have a squared minus b squared or a plus b, a minus b, either one of those. So, okay, this is obviously wrong. This is not right. This does not have the correct terms on the top after you factor the 2 out, so that's not right. This only has one term on the top, but we still have 3 terms. 2 times a squared minus ab plus b squared. Yep, okay, so it's going to be letter H here as the correct answer for combining these rational expressions. Next up, number 52. Here you have this one with the tablecloth, and it's got this little like pattern and everything inside of it. And so the way I chose to do this one, basically you want to know how much is this shaded area is essentially what you're looking for. So you know that each of these small distances here are 2, and the long distances are 36, all the way top to bottom. So the quickest way that I did this is I said, okay, here's a rectangle, here's another rectangle. Each of those rectangles is just 36 by 2, 72 square inches, okay? There's 2 vertical ones, so multiply that by 2, 144. Now, do the same for the horizontal ones. Here's one, here's one. So again, 36 times 2, 72 times 2, so you get another 144 that you add on. Okay, so you get 288. But be careful, that is not the correct answer because you have overlaps that you need to subtract. The overlaps are going to be 4 little squares that are each 2 by 2. So each individual square will have an area of 4, and there are 4 of them, so you need to multiply that, by the the original 4 by another 4 to get 16, and then that is subtracted from the 288 to make 272. So the correct answer for this one is letter F. Now, you can technically split these, long rectangles up into a bunch of small rectangles, and therefore you would not have to worry about the overlaps. And so what I mean by that is you could look at like this rectangle and this rectangle and this one 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 and then this one, this one, this one. But I think it's just way too long to go through. And how many did I have total there? 4, 6, 8, 10, 12, I think. Rather than do all 12 and add them all up, I think it's much quicker to just do 2 long, 2 wide, add them up, and then remember to subtract these 4 little things in the middle. All right, next up, we are going to go over a geometry problem, number 57, where we have a circle and we have an inscribed angle. We also have a central angle. And let's see how we can figure out the measure of ABC. Okay, so we're looking for this angle right here. All right, so let's see here. We have a central angle of 60 degrees. Therefore, we know this angle right here, excuse me, this arc, not angle, this arc BD will also be 60 degrees. Now, we also know that, where is it? They tell you, where is it here in the, okay, chords AB and AD have the same length. This is important because what that tells you is this arc is the same as this arc. So in other words, the measure of arc AB is the same as the measure of arc AD. Thus, if we take 360 minus 60, we get 300 degrees. Therefore, these two arcs are split up evenly from that 300 degrees. So we just take 300 and divide it by 2, and we get 150 degrees each. So this is 150, and this is 150. Again, the reason is because in a circle, congruent chords correspond to congruent arcs. All right, so now there's still kind of two other steps we have to go through in order to figure out the measure of angle ABC. The first is you draw a line, specifically a radius here from point C to point A. The reason you do that is because now it makes a triangle, okay, ABC, that looks like this. Angle C in this triangle, or angle ACB, if you want to call it that, is a central angle, and it corresponds to this arc that is 150 degrees that I just found. In other words, this arc right here, AB, is 150 degrees, and it has the same measure as its central angle. Therefore, this angle right here is 150 degrees. So that means we have 30 degrees left to split up in the triangle between A and B. But the question is, how is that 30 split up? Is it split up the same and they're, just 30 divided by 2, or is like 120 and 110, or how do we know how to split it up? So it turns out that the remaining 30 degrees, again, 180 minus 150 leaves us with 30 degrees, is going to be split up evenly between angles A and B because angles A and B are congruent. Okay, how do I know that they're congruent? Well, because they are across from congruent sides. AC is a radius of a circle, BC is a radius of a circle. The two radii of a circle are equal to each other. Therefore, the angles across from them will also be equal as well. So the measure of angle A is equal to the measure of angle B, which is just going to be 30 divided by 2. Therefore, they will each be 15 degrees. So the correct answer after all that work is just going to be letter B, 15 degrees. Now, below it, we have question number 58. So this one's actually not too bad. It's just a little tricky to figure out, what are the possible values for B and C. So for A, an even prime number, well, there's only one prime number that's even, and it is just 2. So there's only one possible value for A. Now for B, odd integer between 6 and 11. Well, you have 7, not 8. You have 9, not 10. Okay, and then you're at 11, but B has to be less than 11. So there's two possible values. For C, perfect squares between 10 and 30. So here you might have to think a little bit, but it's just going to be 16 and 25 because just think about it. 3 squared is 9, not between them. 4 squared is 16, is between them. 5 squared 25 is between them. 6 squared 36, not between them. So how many ordered triples, different things satisfy these statements? So there's going to be 4, and I mean, you could write that out if you can't see exactly what all the different combinations are going to be. The correct answer to this one is going to be F. But you could also think of it using the slot method. So for A, there's only one choice. You have just 2 and that's it. For the B position, you have 2 choices. For the C position, you also have 2 choices. And now using the slot method, we just multiply these all together and we just get 4, right? It's basically 2, 7, 16, 2, 7, 25, 2916, 2925. Those are our four different ordered triples that you have, which could satisfy these conditions. If you enjoyed this video, if you have any questions or comments on these problems, please do leave them below. Otherwise, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. And of course, as I mentioned earlier, check out my Improve Your ACT Math Score course if you're looking for more resources to help raise that ACT math score of yours.